Good morning, our viewers. Welcome to Noble Tutorials. Now, today we're looking at physics, and this question is coming from the topic elasticity in physics. So, the question says a spiral spin balance is 25.0 cm long when 5 Newton hangs on it, and 30.0 cm when the weight is 10 Newton. What is the length of the spring if the weight is 2 Newton, assuming Hooks law is obeyed? Now, solving this question entails a lot of calculation. Now, the question is coming from NECO 2000. So, this topic or this question is coming from the topic elasticity, and there is a law that governs elastic material, and that law is Hooks law of elasticity. Hooks law of elasticity, and the law states that provided that the elastic limit of an elastic material is not exceeded, the extension of the material is directly proportional to the applied force. So Hooks law states that provided that the elastic limit of an elastic material is not exceeded, the extension of the material is directly proportional to the applied force. Now, the law has a limitation that provided that the elastic limit, that limit is not exceeded, that the extension of the material that is directly proportional to the applied force. So, representing this law mathematically, you have that F is equals to F, the force is directly proportional to the what? Extension. Now, this is a variation symbol, and according to variation in mass, if you want to remove the variation sign, you introduce two things. You introduce an equality sign and a constant. So you have F is equals to KE, where F is equals to the force, K is equals to force constant or elastic constant, force constant, and E is equals to extension. Now, this formula will now help us to solve this particular question that says a spiral spring balance is 25 cm long and when 5 Newton hangs on it, and 30 cm long when the weight is 10 Newton. Now, there is something you have to know, that before you can be able to calculate the extension of the material, you ought to have two things. One, the extension of the material, that is the extension, is equals to the new length minus the original length. The new length minus the original length. That means the new length is that length that the material went after a force is being applied, and the original length is the normal length of that elastic material. Now, the question now says, now we can relate this as E is equals to, let's say that new length is L2, let's say that new length is L2 minus original length is L1. Now, for the first case in the equation, you have that the force there is 5 Newton. The force there is 5 Newton. Now, when 5 Newton hangs on this spiral spring, the new length will now be 25.0 cm. Now, the L2 will now be 25.0, or you can just say 25 cm. That's for the first case. For the second case, when the weight of force is 10 Newton, the new length, that is L2, becomes 30.0 cm or 30 cm. Now, the extension in the first case will now be L2 minus L1. Your L2 is already 25 minus L1, and your extension in the second case is L2 minus L1. Your L2 is already 30 minus L1. Now, we are meant to calculate the L1, that is the original length for this material, because this spiral spring balance, both in the first case and the second case, the L1, that is the original length, will definitely be the same. So according to, from Ohm's law now, from Hooks law, you have F is equals to KE. Now, your force in the first case is 5 Newton is equals to K times, your extension is now 25 minus N1. So, if I want to make K a solid of the formula, I will divide both sides by 25 minus N1. 25 minus N1. So, cancel out. You have that K is equals to 5 over 25 minus N1. This is your equation 1. Now, going to the second case now, we have F is equals to K. Your F is 10 Newton. Your K is unknown. Your E is now 30 minus N1. So you are looking for K. Divide both sides by 30 minus N1. 30 minus N1. So when you now cancel out, your K is equals to 10 over 30 minus N1. Your equation 2. So now, you see that this equation has led us to simultaneous equation in mathematics, and it's very easy and simple to solve. Now, it's very easy because you can say equate both equations. You are equating the both equations because they have the same subject of the formula, and each subject of the formula in each equation has the same coefficient. So you can equate them and you'll be having 5 over 25 minus N1 is equals to 10 over 30 minus N1. So you do what? You cross multiply. So you have 10 in bracket 25 minus N1 is equals to 5 in bracket 30 minus N1. So if you want to cross multiply, you cross multiply like this. So you have, now 5 can divide itself, giving you 1. 5 can divide 10, giving you 2. So 2 times 25 is 50, minus 2 times L1 is 2 L1 is equals to, what is now remaining here is 1. So 1 times 30 is 30, minus 1 times L1 is L1. So you collect like terms. Collect like terms. So you have 50 minus 30 is equals to minus L1 plus L2 L1. So we now have 50 minus 30 is 20 is equals to minus L1 plus 2 L1 will now give you L1. So therefore, your L1 is 20 cm. So your L1 in this case is 20 cm. So can we now get the force constant, that is the K? We can get the force constant. We can either use the first case or the second case. Whether you use the first case or the second case, you will still get the same answer. So you have E is equals to L2 minus L1. I'm using the first case now. In the first case, your D length is 25.0, or let's say 25, minus your old length is original length is 20. So when you have 25 minus 20, you'll be having that your E is 5 cm. Even if you go to the second case, you will still have the same answer. Okay, we now have that F is equals to KE. Now, the question now says we are trying to get our constant. Now, in our constants now, you have F, your force is already 5 Newton. Is equals to K is what? Another 5 times, K is unknown times E, which is now 5. Your E is 5. So, you can now divide both sides by what? 5. When you divide both sides by 5, your K will now be 1.0 Newton per meter, because the unit of the force constant in elasticity is Newton per meter. Now, the question now went further to ask, what would be the length of the spring? If the weight is 2 Newton, what would be the length? Now, for you to calculate the length, you are still using the F is equals to KE formula, that your F is now 2 Newton is equals to your K is 1 times your E is unknown. Before you can get the length, you need to get the extension. So you now divide both sides by what? 1. Divide both sides by 1, and your E is now 2 cm. Now your E is now 2 cm. What will be your force? What will be your new length? If your extension is 2 cm, what will be your new length? So you have E is equals to N2 minus N1, and E is equals to, your E is now 2 is equals to N2 minus your L1 is already 20. So your L1 is already 20. So when you collect like that, this one goes over with plus. I have 2 plus 20 is equals to N2. 2 plus 20 will now give you 22 is equals to N2. And therefore your N2 is equals to 22 cm. And that will be the answer. So thank you. If you haven't subscribed, make sure you click our subscribe button and subscribe. Thank you very much. Now in this video we are going to be looking at tensile stress, tensile strain, and Young modulus in elasticity. Now the question says a force of 40 Newton is applied at the end of a wire of length 4 meters and diameter. So we have a force of 40 Newton. We have a wire of length 4 meters. We have the diameter 2.00 millimeters. And we have extension at 0.24 millimeters. So the question says calculate the Young modulus of the material of wire. So I can say that we should use our pi as 3.14, not 3.114 in this case. So, and the question is coming from wire 2003. That should be a theory question. Now, if you want to start, you have to know that the first question says calculate the stress on the wire. When you talk about stress in the elastic material, the stress is given as force over area. That's the formula for stress. Now, the stress now is equals to your force is 40 Newton all over. The area you are going to be looking at is the area of a circle, which is pi r squared. And you have 40 all over. Your pi is 3.14 times. Now, your radius wasn't given, but you have a diameter. And the formula for radius, when diameter is given, is d over what? 2. So your diameter is now 2.00, which is also 2, divided by 2, and you'll be having 1 millimeters. Now also note that you cannot be solving a question in physics when the unit is in millimeters. We have to change it to meters. And when you have millimeter changing to meter, you divide by 1000. So when you divide, change this thing to millimeter, you divide by 1000, and you probably have 1.0 times 10 raised to the power minus 3. So you have this, you have 14 all over 3.14 times 1 times 10 raised to the power minus 3 times 1 times 10 raised to the power minus 3, because the r is raised to the power 2. So we have 40 all over 3.14 times 1 times 1. You still have 3.14 times 10 raised to the power minus 3 minus 3. So we have 40 all over 3.14 times 10 raised to the power minus 3 plus 3 is minus 6. We have minus 6. So it's equals to 40 divided by 3.14. You'll be having 12.74. Where you have, okay, let me write it in. We have 12.3885 times 10 raised to the power. Now, when minus is crossing division sign indices, it will not change from minus to plus 6. So you now have 12.74 times 10 raised to the power 6. And the unit of stress, will now be Newton per meter square. So the unit of stress is Newton per meter square. Okay, to 2 decimal places. I approximated to 2 decimal places. Now, the second question, the pass is strain on the material. The strain of an elastic material is equal to extension over length. And the extension we have is 0.24 now millimeters. Now changing that millimeters to meters, we have 0.24 times 10 raised to the power minus 3. And but your length is 4 meters, direct 4 meters. So you use 4 to cancel 0.24. When you have 0.24 divided by 4, you'll be having 0.06 times 10 raised to the power minus 3. Now, strain of the material doesn't have any units because the unit of extension is meters and the unit of length is meters. So meters can cancel meters. So the strength of the material doesn't have any units. Now the young modulus, that is the C part. Now, if you haven't subscribed, make sure you hit the subscribe button to follow our page, our videos for more tutorial classes. Now, this young modulus of this material is given by stress over strain, and your stress is already 12.74 times 10 raised power 6, all over strain is 0.06 times 10 raised power minus 3. So you have 12.74 divided by 0.06, we'll be having 212.33 times 10, okay, yes, times 10 raised power 6. Now, the division itself is minus, and the power in the denominator side is also carrying minus 3. So you have 212.33 times 10 raised power 6, minus is now plus 3. And we are having 212.33 times 10 raised power what? 9. 6 plus 3 is 9. And the unit of young modulus is Newton per meter squared. And this is all about tensile stress, tensile strain, and young modulus. Thank you very much. And this one says a force of magnitude 500 Newton is applied to the free end of a spiral spring of force constant 1.0 times 10 raised power 4 Newton per meter. Calculate the energy stored in the stretched spring. Now, solution. Now, the energy stored in the stretched spring is given as work done, which is equal to 1 over 2 Fe. Now, you cannot use this formula, you can also have the formula of or. Now, since you know that from Hooks law that F is equal to K E, when you now substitute this K in the F, you have 1 over 2 in brackets K E in bracket E. This E now is what we have here. So when you open the brackets, you have 1 over 2 K times E is now E raised to power 2. Now the work done in a spiral spring or the energy stored is equal to 1 over 2 Fe or 1 over 2 K E squared. Now, if you look at the parameters that are given in the equation, you have a force of 500 Newton and a force constant of 1.0 times 10 raised to the power 4 Newton per meter. Now, but in the two formulas that you can use, you need the extension of the material, but in the equation, the extension wasn't given, and that's not a hard thing to get because you know that F is equal to K E. Your force is 500, which is equal to your K is what you are looking for. Okay, your K is 1.0 times 10 raised power 4 times your E is what you are looking for. So you can now divide both sides by the coefficient of E, which is 1.0 times 10 raised power 4. Okay, when you divide, you have your E is equals to 1.0 times 10 raised power 4, which is now equals to 500. You have 500 all over 1.0 times 10 raised power 4. 1.0 is still 1. So 500 divided by 1 is 500 times. Then when plus 4, because this is plus 4, is crossing the division sign, it changes to minus. So you have times 10 raised power minus 4. Now changing it to standard form, you now move 1, 2. Moving like this, you are going in a positive direction. So you have E is equals to 5.0 times 10 raised power minus 4. You move 2 times in a positive direction plus 2. And E is equals to 5.0 times 10 raised power minus 2. And viewers, if you haven't subscribed to our YouTube channel, make sure you hit the subscribe button and follow us for more interesting videos. So we will continue with our question. You can either use, since you are getting your E, you can either use this formula or this formula. Anyone you use, you are going to get the same answer. So you have the work done is equals to 1 over 2 times your force is 500. I'm using the first one. 500 times your E is 5.0 times 10 raised power minus 2. Our work done is equals to 2 divided 500. You have 250. You have 250 times 5.0 times 10 raised power minus 2. So we have 250 times 5.0. You have work done is equals to 1250 times 10 raised to power minus 2. 1250, that's 250 times 5.0. Now, changing it to standard form, you have 1, 2, 3. So you'll be having, or basically you can say 1250 times 10 raised to power minus 2. Since you have minus 2, you can go as 1, 2. and your work done will be 12.5. Now the unit of work done on anything stored in a spiral spring is joules, which is denoted as J. So your final answer is 12.5 joules, and that is the correct answer. Thank you very much.